All right, we're the plant identifier team. I'm Dan. I'm James.
I'm Nick.
All right, what we've done is we've created a mobile website that will help you identify various plants that you find via picture or attributes. So the motivation for this was basically, say you're walking down the street, you see a flower you like, think your girlfriend would like, but you want to know maybe it's poisonous, maybe it gives a rash, something like that. So you take a picture of it, and our app will get you more information about it. And if you just want to know the name, so you can order some from actual flowers instead of picking it out of the ground, so it doesn't hurt on it. Maybe real nice. Here are some of our requirements. Want to talk about that?
So first of all, the application must be able to take a picture. It has to be connected to a database of plants that we have. So has to identify the name of that plant that it searches. Must display basic information. Return like the top three most likely results that plant is to be. Basic information is in the picture. And then once you click on one of those results, you'll be given a much more detailed list of color, average size, location, scientific name, common name, and a link to that plant's Wikipedia page. So the application also provides the ability to search all plants in the database based on a certain set of attributes. And then you can also select settings that are select what information of that list will be displayed in the slide.
This is our basic architecture. It does require internet connection to work. It is formatted for mobile devices. So here we have, say, an iPhone. We connect to the internet to a server, which also has our database server.
This is our screenshot of our database. It was populated with information by just randomly selecting plants for the internet. I didn't go through with the specific ideas of get certain types of plants or similar plants, just random ones. I try to make them as variant as possible of what our algorithm. We used Microsoft SQL Server 2012 and communicated with the
This is a very simple database. We didn't have time or the energy really to just keep on going and adding more stuff. It's data, just inputting data is very time intensive and a real pain. So,
That's useless. Is it on your picture now?
With more time and resources, we could have created a much larger normalized database with more pictures and a lot more useful information. Because we don't have all that information, this is why we have the Wikipedia, which are way cheap. So Nick's going to talk to you about our image processing algorithm. There's more to the future.
Right.
It works.
Anyway, so you have an image. What we're doing with this algorithm is taking this image and dividing it into squares or pixels. Basically what happens is the algorithm goes through for each pixel, it's a for loop. Each iteration will go pixel by pixel, length times height, and it pulls a red, green, blue value. There's a PHP function that does that for it. And it takes this value and dropped it in array. RGB. R. Wow. This is not the effort.
Throw things for you to
RGB pixel. So you're going to get value in each of these cells of this array. And what we do is take a composite value of the values in this array and get one big average value. Jim and I ran through each of the 60 plans that are in the database to get a comparable value. And what this algorithm does is it goes through, it pulls an algorithm from the image you just submitted, and it subtracts the one value from the second value. And whenever it's closest to 0, it also set up your SQL commands to pull up the top 3 results using a label. Basically.
This is also a very simple algorithm.
Yeah,
That's not very accurate.
in being that only compares by color.
It is average color value, so
There's going
to
to
get an
be
exact match, and you take a picture of the exact image we have in the database. Again,
basically
this is
background colors and just a car in the background of the picture. That's
This
going to
is,
skew the data.
Yeah, this is a limitation of our time and resources. I'll show you the actual website. So here's our plant identifier website. Another reason we chose to make it a website and not an app, which is what we were originally doing, is because this is localized and it'll work on any device. It doesn't have to be mobile, it just has to be HTML5 compatible. So say you want to know about plants. We're going to identify a plant. We have the two options. Jim will show you the images and he'll talk a little bit more about this shortly. But say you just want to identify something by attributes. So we have, these are our attributes. Scientific name, common name, color, size is large, medium, small. Again, our database is not all that deep. Type is also tree, bush, or flower, I believe. Location is by hemisphere, yes. So you can search by any one of these, and it'll give you the list of plants that match any of them. So say I just want to know northern hemisphere plants. There we go. We have a list that is populated dynamically. Say we just want to know about the white oak. Nice little picture of the white oak. Its common name, scientific name, size, that kind of stuff in a nice little Wikipedia link here to learn more about it. Wikipedia looks better at that size on mobile device. So Jim's going to show you on the actual phone.
See that?
There's
Light above that?
all ones.
Yeah.
Oh.
Turn off the light.
Oh, there you go. Is it phone? Oh.
There we go.
Alright, so here's the insight. It's very similar to what Dan showed off the internet on the computer. You have your main options, we have like the about us, which is very brief information, just saying that you go to open, you simplify this project. One feature we have added is you click on the icon at the top, it takes you automatically back to the index page. So anywhere you are in the site, you can go get back. I'll show by first identifying by an image. So just basically a file upload. Choose your file. You're going to have you take it by a camera or a picture in your gallery. Here, that's images. There's one of the trees. It says the chestnut is the name of the file. When you search, it'll run the algorithm, it'll get the top 3 results. The top one's obviously the same picture of the chestnut. So, and then the two closest to this. And again, you can go into the site for whichever one you want. I didn't change. We can go back to the home page, go to the settings, and see each of these checkboxes on the go in and check. You don't need to sign anything like save the setting, save, rewrite the one page after a couple seconds. You can go back, identify the save point. And you go to the site, choose one. They'll have the picture, all the things you broken up. It doesn't have the color, size.
Color size.
Size, yes. You can see that again. You go to the Wikipedia link and show. It's got good information in case you want to actually learn more about that. The other function, one of the actually the happy things we found about this is you can do it with any picture. It doesn't matter what it's like. So we were sitting in the lab working on this. We took pictures of people and just used that. So what I'm going to do is I'm going to take a picture of you guys and we're going to see what this point are. Maybe the lens on them.
I wasn't sure about the first time we tried this.
So I've got that image. We'll see what we all are. You all are. You are a blue morning glory. There you go.
You are skewing your previous results.
The show, believe it or not, they're all wallflowers.
Our previous presentation, our classes made of wallflowers. That's what we learned. That's great.
So,
Yep, that's our presentation.
Any questions?
For tracking, I guess tracking in the back end, you submitting what pictures, requests?
The pictures and the database is populated by us. It's not populated by the
Yeah, but
users.
the files you upload, you're uploading files, right? They're somewhere.
It's
Yeah,
putting a
no,
template.
it's just temporary. It gets deleted as soon as after it's run through the algorithm.
How are you storing these settings? So are you separate settings to go back in? Or you
They're stored in cookies. It's actually
The
intro page.
when you go to the page, I think he was just in the home page, but there is a PHP page that sets your cookies. If you go to just right here, that'll set all the cookies. But he didn't do it next time. I did when I put it up on the computer, which is why I had everything selected first.
What do you usually do to compare the pictures?
Just the algorithm, so it's not like after the algorithm comes up with a value.
Like you guys like a C# app, that's one we did them to, like, compare or.
That was a PHP.
That was PHP, yeah.
It's PHP.
PHP.
That's what takes gives us the average color value. That's
PHP does a nice collection, a library of image functions for that type of purpose. So we had to put a PHP, make it a configure our server for PHP also.
Is there any other questions?
Do you have an average server load that takes that?
No, but we did notice that when I was taking pictures with my iPhone at the highest resolution, it took quite a while and upload, even on our nice speedy little Wi-Fi here.
It has to go through 1,400 pixels, pixel by pixel.
How we could have done it to speed it up, we would have limited the size of the picture. Because it's not just going through the algorithm, but the sheer upload is large. So.
I've actually done this before, not identifying plants, but I've taken pictures of plants to find out what they were. It's a nursery.
Well, there you go.
It kills them.
That'd be more good information to have.
But I have done that.
Any other questions? Thanks for your time.